Take the derivative of y, you need to write
Right lower.
dy dx. Okay. So what's going on between the x squared and the y? You're multiplying, so you have to use product rule. So x squared times the derivative of y, which is dy dx, plus y times the derivative of x squared, 2x, plus, and then we have to take the derivative of this part too, which is a product also. So x times the derivative of y squared is 2y dy dx, plus y squared times the derivative of x is 1 is equal to 0. Okay, any questions there? Okay, now we need to solve for dy dx. So let's keep everything with dy dx on the left. Everything else goes on the right. So x squared dy dx plus 2xy dy dx equals to negative 2xy minus y squared. What do we do here? Factor. You factor out the dy dx, and then we have x squared plus 2xy left over. Divide both sides by x squared plus 2xy. You can just move some of those boxes down. So dy dx is equal to this right here.
Am I right? Dx over dy will have a different meaning.
Yeah.
Are we gonna have to do that sooner or later? Or
No. Wait. No. You think that it steps around -1
Yes.
and that
Yes. Yes, you can. Alright, number 2 and 3. So 2 and 3 are pretty similar to this. Okay, so I'm not going to do those two. 22, 24, 25, 22, 26. Alright, let's look at 22.
Right lower.
I'm really confused. This is I think so. This is Mr. Chang's calculator. Well, this is 425. What are you looking for?
Alright.
Yeah, that's then not here. Okay, no problem. Bye.
Alright, let's take the derivative. So we got 2x minus square root of 3. And then let's open up parentheses, because we are going to take the product rule of x and y. So if there's a number out in front, you can just put it outside the parentheses first. And then deal with it later. So x times the derivative of y is x dy dx. Plus y times the derivative of x is just 1. Plus, so we're going to have the power rule here, 4y dy dx is equal to 0. Alright, questions so far?
Wait, so we just ignore the 5?
No. What's the derivative of 5?
Oh.
Alright, let's distribute the square root of 3.
Yep. Yeah. Well, no one should be in 425, so there was a switch made, but his classroom was really 210, but otherwise 425 was completely empty. Yeah. No, but your age just probably been going to like Popeyes or something, and then, yeah. No,
Okay.
so this is Jack Lake, and I have 425, so no one's ever here, because, yeah.
So,
they changed it, so
let's move these two over to the other side. We'll leave anything with dy dx to the side. I'll rewrite the x first, just so that it's clear that it's not inside the square root sign.
Oh, no, so he uses this class for like 1 period a day, for 7 periods, so we share the classroom. Yeah. Yeah.
Is equal
exactly.
to
Yeah, so I'm just working and he's
minus
sitting.
2x
Yeah.
plus.
I would try
Y
like
square root 3.
427 or 429. I think we changed it because are you looking for the tutorial?
Yes, I just
class,
moved
or-
it. It's just so that it's clear that the y is inside the square root. It's not inside the square root.
Oh.
Factor out a dy dx.
Who's your aide? Yeah, because I don't know.
Alright, and then divide both sides by the parentheses. Okay, I'm gonna. You guys don't need to see me do that, right?
Oh no problem. Yeah, I would. Okay, I know 426 sticks. I know that there's some other classes in 427 and 9. I would try one of those. Yeah.
Alright, questions? Oh, what's the question asking? Find the lines that are tangent and normal. Okay, so we're not done yet. Alright, so the point that they give us, square root of 3, 2. So anywhere you see an x, you plug that in. Anywhere you see a y, you plug 2 in. And then let's figure out our slope. So we got negative 2 square root of 3 plus 2 square root of 3 over negative 3 plus 8. Well, that already is 0. So your slope is 0? Is that right? Yeah. So what you guys got? So what you got? Yeah. That's what you got. That's probably right. Okay, so if your slope is 0, then now that you write your equation, alright, so our slope is 0, so y equals
B.
b.
You're supposed to find the slope, that's
You sure?
Find the line.
Find the line.
Yeah, find that.
Yeah, find the line.
Alright.
Alright, well, when we plug y, so b is going to be 2, so there's an equation, normal, and that should, and there is no, this is the equation tangent, and there is no equation normal because there's no reciprocal of 0. Okay, so this is tangent right here. And there's no normal line. Alright, questions there? Does that make sense?
Wait, how did we know there was a normal?
Because, so the slope is 0, right? So to find the equation of the line tangent, we use this slope. To find a normal line, it's the negative reciprocal.
Yeah.
There's no negative reciprocal of 0, because you can't flip 0. Alright, any other questions with this one? Alright, let's look at number 24. and then we'll move on. You guys want to see 24 or 26? Pick one. Alright, 26.
Oh, whoa.
Was that box in your way? Alright. So we're going to take the derivative. So here we have to do the product rule. Okay, but within the product rule we're going to end up doing the chain rule. So you want to make sure you pay attention to this. So we have x squared times the derivative of cosine squared y, which is 2 cosine y. Now we didn't take the derivative of y yet, because what we really did was do the product rule, so we don't need to write dy dx. But now that we're taking the derivative of cosine y, which is negative sine y, here we do need to write dy dx. Alright, any questions there? So let me explain this part real quick. Cosine squared y, the same thing as cosine y squared. To take the derivative of this, you do the power rules. 2 cosine y times the derivative of the inside, which is negative sine y. But now that we're taking the derivative of that, dy dx.
So the first part, like the 2% y, you don't need dy dx.
No, because you didn't take the derivative of y yet. You just did the power rule. Alright.
Mr. Kane,
Yep.
can you go to the bathroom?
Yep. Plus cosine squared y times the derivative of x squared is 2x. Alright, any questions there? Minus derivative of sine y, cosine y, dy dx is equal to 0. Okay, let's keep dy dx on this side, everything else goes on the other side. I'm going to reorder this also. It's negative 2x squared sine y cosine y dy dx minus cosine y dy dx equals to negative cosine equals to negative 2x cosine squared y. Right. Questions? Factor out the dy dx. We have negative 2x squared sine y cosine y minus cosine y is negative 2x cosine squared y. The dy dx is equal to negative 2x cosine, we can cancel out the negatives. So cosine squared y over 2x squared sine y cosine y plus cosine y. Are any questions there? that's just the derivative of that. Okay, let's figure out what the slope is. So we're going to plug in 0 for x, pi for y. So we got 2 times 0 cosine squared pi over 2 times 0 squared sine of pi cosine of pi plus cosine of pi. Alright, questions there? So all that simplifies to 0. Right, because that's 2 times 0 times anything else is 0. And it doesn't matter what's on the bottom anymore because 0 is on top. Yeah?
Good difference actually.
Okay. It's probably the same thing, but like things are moved around.
Yeah. Probably. Yeah.
Okay. Alright. Any questions here? So your tangent line again. Y goes mx plus b. So here's tangent. M is 0. Y equals b. Plug in pi for y. So then your equation is y equals pi. And then there's no normal line.
Wouldn't the same thing be the normal line?
No, because the normal line has to have it is perpendicular.
Yeah.
So I guess the normal line could be x equals. No, hold on, with you. Y equals pi.
Yeah. So it makes it. Because if you do it out mathematically, it gets the same thing. This is going to be the same as 0. But perpendicular, that would actually be.
Yeah, but where would it be on the along the x-axis? So that's pi. We know it goes this way, so it's x equals a number. I think it's gonna be x equals 0.
0.
I think so. Let me check. Yeah, so this one is x equals 0. So here's a perpendicular line to that. So in your other one, what number was the other one? 23? 2? Square root of 3 was the normal line.
So x equals 0 is the normal line, right?
Yeah. No, you're right. Alright. So, alright, questions? Okay.